I'm Ritika, this is Sanjana, this is Safrin, this is Sanjay Darshan, this is Sudan, and this is Rekha. Today we are going to do a case study on Dining Philosophers Problem, which is a classic synchronization problem, where it illustrates how multiple processes can complete on limited resources, and it ensures how it can be done efficiently. Now Sanjana will describe about the problem.
So let me talk about the problem overview. So this problem states that 5 philosophers sitting on a round table each have a separate bowl of food and they need to use 2 chopsticks to eat the food. So here the philosopher alternates between thinking and eating, and the main challenge here is only one philosopher can eat the food at a time because only one chopstick is placed between each philosophers. And let us see that how this problem can be solved. Can anybody explain how this can be implemented in a real-time way using an algorithm? Yes. No.
In this code, we solve the dining philosopher's problem using semaphores and a signal variable. Each philosopher thinks, then tries to pick up 2 forks. We use a mutex to make sure only one philosopher changes state at a time. When a philosopher gets both forks, they start eating. After eating, they set signal of I equals to 1 to indicate they are done and realize the forks. Then we check if the left or right neighbor can eat now. This avoids deadlock and ensures all philosophers can get chance to eat without starving.
Can you give me what are the advantages of this particular dining philosopher problem and how it can be applied in the real-time examples?
The advantages of the dining philosopher is to simplify a complex subjects like to defining the allocation, the program allocation, the starvation, and we can talk to avoid deadlock. That simplifies this and avoid to educational value. It use the ideas to the operating system and the concurrent programming and use the idea about the design thinking also to avoid the starvation and deadlock. To avoid this, we think creatively and to avoid this.
So definitely there must be a real-time application for the synchronization issue. So can you tell me some of the cases where it can be applied?
Yes, the real-world application of this dining philosopher problem includes that in database system we will be using transaction in multiple blocks to implement this, and we will also using networks which is using dining philosopher problem, and we will be using for managing input or output devices.
So what can be the challenges when we implement the dining philosophy problem?
There are 3 advantages in this: deadlock, starvation, and concurrency. In deadlock, where each and every one of philosopher takes a chopstick, where it leads to a deadlock, where no one can eat or drink. In starvation, where 2 philosopher or 3, they take the chopsticks and when they eat, the others has to wait, and repeatedly when they continue to eat, the others has to wait, so it leads to starvation. And in concurrency, where the philosopher eats and switches to the others, and it continues where everyone can eat.
I hope it is a parallel process.
Parallel processing.
Okay. Okay. So thank you guys for your wonderful case study explanation on dining philosopher problem. So this is very interesting problem in the operating system where it is chosen for the classical problem of synchronization. Thank you.
Thank you.